James Webb Telescope discovered a new quantum gravity sensor for the multiverse. As everyone knows, the James Webb Telescope is the world's most powerful and largest space telescope that has ever been built. It will let scientists peek back 200 million years after the Big Bang to see how our cosmos looked. It will take pictures of some of the first galaxies that may have been created. Moreover, it will be able to see inside dust clouds, see where new planets and stars are forming, and observe the atmospheres of planets orbiting other stars. Additionally, it will be able to observe objects and artifacts in our solar system from beyond Mars. And on top of that, the team thinks they may have discovered a new quantum gravity sensor for the multiverse. So in this video, we will be talking about the James Webb Telescope and its fascinating new discoveries. Watch this video until the end to know about all these new discoveries. Also, hit the subscribe button and turn on the notifications to get new updates about space-related discoveries. And don't forget to hit the like button. Let's begin with quantum gravity sensors for the multiverse. Finally, a subterranean object has been found through quantum technology, a long-awaited milestone that has far-reaching implications for industry, advancing human knowledge, and maintaining national security. Researchers from the University of Birmingham's UK National Quantum Technology Hub in Sensors and Timing have published their findings in Nature. It is the first time a quantum gravity gradiometer has been used outside of a laboratory. The quantum gravity gradiometer, developed under a contract for the Ministry of Defence and as part of the UKRI-funded Gravity Pioneer project, was used to locate a tunnel buried outdoors in real-world conditions, 1 meter below the ground surface. It triumphs in an international race to bring the technology outside. The sensor detects variations in microgravity using quantum physics principles, which are based on manipulating nature at the submolecular level. It is believed that this success will lead to a commercially viable plan that will improve the mapping of what exists beneath the surface of the ground. By doing so, construction costs will be reduced and transportation projects will not be delayed. Natural phenomena such as volcanic eruptions can now be predicted more accurately. There are now hidden natural resources that can be found in constructed structures that can be explored. There are now archaeological mysteries that can be investigated without jeopardizing archaeological excavations. And talking about the James Webb Telescope, it discovered this new quantum gravity sensor for the multiverse. It states that when an atom cloud is dropped, the quantum gravity sensor detects the subtle changes in the pulling strength of gravitational fields. The stronger the measurable difference in pull, the larger the object and the greater the difference in density between the object and its surroundings. However, vibration, instrument tilt, and disruption from magnetic and thermal fields have made commercializing quantum theory difficult. The Birmingham quantum sensor breakthrough is the first to address these real-world challenges while also performing a high spatial resolution survey. In addition, the removal of vibration-induced noise will also enable high-resolution gravity mapping. The James Webb Space Telescope views the cosmos in a light that human vision cannot perceive, as infrared radiation is the name for this type of light, which we can perceive as heat. Firemen use infrared cameras to see as well as rescue individuals amid smoke inside a fire. Likewise, the James Webb Space Telescope would see through dust in space with its infrared cameras. In fact, peering into stars and planets could lead to fascinating discoveries. It could also monitor objects like early galaxies that are so far away that their radiation has shifted from visible to infrared as the cosmos expands. Unfortunately, the Webb's telescope's cameras are susceptible to solar heat. Webb has a sun shield to preserve its instruments as well as mirrors, similar to how you could use a hat or visor to hide the sunlight from the eyes. The sun shield on the telescope seems to be about the length of a tennis court, and the difference in temperature between the telescope's sun-facing and that of the shaded sides is over 600 degrees Fahrenheit. But what are the challenges it faced? Well, Webb was supposed to launch in 2018. The project's purpose, when it first envisaged in the 1990s, was to deploy before 2010. But on December 25th, 2021, the James Webb Space Telescope was finally deployed. So why did it really take almost 30 years and over $10 billion, approximately $14 billion, just to get Webb up and running? Well, first, it has a gold-coated mirror, which is 6.5 meters in diameter, especially in comparison to Hubble's 2.4 meters, making it the world's biggest telescope ever sent into orbit. The overall building had to be compressed to accommodate within the nose cone of just an Ariane rocket, which added to the complication. And second, there have been two significant engineering feats to complete with Webb. So that's why it took so long to launch. Anyway, continuing to the telescope, its mirror surface must be positioned along an arc with exceptional precision for a powerful telescope to generate the finest images conceivably. Webb's task entails unfolding and aligning the core mirror's 18 hexagonal pieces and a secondary mirror to an accuracy of 25 billionths of a meter. And Webb will also be detecting infrared light, which necessitates keeping it extremely cold, about minus 233 degrees Celsius, in order to boost its sensitivity. This means it has to be separated from the Earth, which is a source of light and heat. It must also be totally sun-protected, which is accomplished by using a 20-meter multi-layered sun shield. So what is the current state of this telescope? Well, so far, every optical parameter evaluated and verified has operated as expected or better, with no major difficulties or obstructions in Webb's optical route. All of this implies that the jwst can now capture light from much farther away objects and send it to its sensors without difficulty. And moreover, the remaining alignment stages will take place over the next 6 weeks. An algorithm will review the efficiency of each instrument throughout this stage of the procedure. After that, the final adjustments would have to be made in order for the telescope to be correctly aligned could be calculated. In the meantime, the photographs have been returned, which are excellent initial indications of the telescope's capabilities since they demonstrate what it's capable of during the alignment process. Pretty nice, right? Spoiler, the first image is likely to be unveiled in the summer. But what are the discoveries that it is expected to make? Well, the fact that jwst is largely an infrared telescope, while Hubble is predominantly a visible light telescope, is one of the reasons for its power. Since this earliest light in the cosmos has now been shifted into the infrared, it makes the infrared extremely powerful. This enables jwst to stare beyond and further into the universe, detecting entities that Hubble would be unable to see. jwst, for instance, will enable us to photograph the universe when it was only 100 million years old. On the other hand, infrared light may penetrate through dust, although visible light cannot. So as a result, jwst will let us see beyond dusty and veiled areas of the universe, such as star nebulae. But the question might arise, what will we discover now that we have access to the universe? Well, theoretically, there are 5 most important discoveries jwst is expected to make. First is, what was the appearance of the first black holes? And why is there a supermassive black hole in the heart of every galaxy? So a supermassive black hole is found to be present at the center of each and every galaxy. However, the precise form of these behemoths remains a mystery. According to current views, the initial stars might well have collided to create these giants, but we don't know how they grew so large so rapidly, generating the very bright quasars which we could still see after 13 billion years. So the jwst is expected to allow us to look back as well as learn more about their origins. Next is, how are planets and stars formed? So it can be seen that inside a stellar nebula are celestial bodies that are usually hidden by dust. Therefore, it is currently difficult for scientists to define the exact mechanism of star system creation. For example, as per NASA, we don't know if our solar system is normal or uncommon, or why numerous stars develop in clusters. So we ought to be able to see the entire innards of these systems with the Webb telescope and record protoplanets and protostar development. Determining whether our solar system is normal or exceptional might even aid our understanding of our role in the universe. Next is, what can be said to be the true expansion rate of the universe? Cosmologists recently discovered differences in several measurements of the rate of expansion of the universe. The disparity is referred to as the Hubble tension, and it results from exchanging notes on observations of nearby galaxies as well as the cosmic microwave background. On the other hand, dust obscures the accuracy of local measurements, which jwst could address. So, scientists will understand if this difference signals new physics or whether it is merely measurement error with subsequent, more exact observations. Another expected discovery is, what did galaxies and stars look like in the beginning? So according to scientists, the universe's first few 100 million years are built on various assumptions. Unfortunately, our hypotheses about how the first set of stars as well as galaxies was formed as dark matter halos condensed lack observable data to perhaps validate or refute them. It's because the early universe could only be seen in the infrared, which means a telescope the size of jwst would be needed to photograph it. By using the data from these observations, we can talk about how the first stars and planets evolved in the galaxy, which will have major implications for cosmological theories, especially addressing the mystery of dark matter. Next is there a planet that is similar to Earth? Or is it possible to find life elsewhere in the solar system and even beyond? jwst will allow us to see big exoplanets properly and get spectroscopic measurements of a bunch of others. This is important because it allows us to figure out the chemical composition of extraterrestrial atmospheres. If any of them have life, they might have chemical element proportions different from what would be typical geochemically. Moreover, it's also conceivable that we'll find these alien biosignatures, particularly in close star systems like TRAPPIST-1. And with this, we come to the end of this video. So this is all about the James Webb Space Telescope and all the discoveries that it is going to make. Let us know in the comment section below, and if you like this video, then don't forget to hit the like button and subscribe button if you are a real space junkie. See y'all in the next one. Until then, peace.